Welcome to this lesson on the third derivative test, also known as the higher derivative test. This method helps us classify a stationary point when the second-order condition cannot provide an answer. Before learning the third derivative test, let's quickly review the second-order condition, a local minimum, while a negative second derivative indicates a local maximum. But what happens when that's when we need another test? When the second derivative is equal to 0, in this situation, we continue by finding the third derivative. This is known as the third derivative test, or the higher derivative test. Here's the process. First, find the stationary point by setting the first derivative equal to 0. Next, evaluate the second derivative. If it equals 0, the second-order test is inconclusive. If the second derivative equals 0, the second-order test is inconclusive. We then find the third derivative to classify the stationary point. Let's understand the third derivative test. Consider the function y equals x cubed. We'll determine the nature of its stationary point by applying the higher derivative test step by step. First, differentiate the function. The derivative of x cubed is 3x squared. Next, set the first derivative equal to 0. Solving 3 equals 0 gives x equals 0. Now differentiate again to obtain the second derivative, which is 6x. Substituting x equals 0 gives a second derivative of 0. Next, differentiate the second derivative one more time. The derivative of 6x is 6. Since the third derivative is not equal to 0, the third derivative test tells us that this stationary point is not a local maximum or a local minimum. Notice that the graph passes smoothly through the stationary point, instead of turning. The tangent is horizontal at the origin. The curve changes from concave downward to concave upward. This confirms that the point is a stationary point of inflection, not a local maximum or minimum. Because the third derivative is not equal to 0, the stationary point is not a local maximum and not a local minimum. Instead, it is classified as a state of inflection, where since the second derivative is 0, we move to the third derivative. If the third derivative is also 0, the test is still inconclusive, and we must continue checking higher-order derivatives. Now, we look for the first derivative that is not 0. This first non-zero higher-order derivative tells us how to classify the stationary point. If the first non-zero derivative is of even order, the point is either a local maximum or a local minimum. The sign of that derivative determines which one. If the first non-zero derivative is of odd order, the stationary point is neither a maximum nor a minimum. It is a stationary point of inflection. Let's summarize the higher derivative test with a simple decision tree that works for every stationary point. Consider the function f of x equals x to the fourth. At x equals 0, the first derivative, second derivative, and third derivative are all 0, but the fourth derivative is positive. Because the first non-zero derivative is the fourth derivative, which is an even-order positive derivative, the stationary point at x equals 0 is a local minimum. Remember this simple rule. Find the first non-zero higher-order derivative. The sign determines a maximum or minimum. If its order is odd, the point is a stationary point of inflection. Thanks for watching. If you found this lesson helpful, please like, share, and subscribe for more mathematics tutorials. Don't forget to leave your questions or comments below. See you in the next lesson.